this video is about the product rule and the quotient rule. In the MF19 we have this formula. The du dx is u prime, the dv dx is v prime. So the formula, if we have y equals u times v, the y prime is u prime v plus v prime u. So for example, if we have y equals 2x cubed plus 4x to the power of 5 times x to the power of 6 plus 7, if we just expand one by one, we get 2x to the power of 9 and 2x cubed times 7, 14x cubed. 4x to the power of 5 times x to the power of 6, we get 4x to the power of 11. 4x to the power of 5 times 7, we get 28x to the power of 5. And if we arrange in a descending power of x, we have 4x to the power of 11 and 2x to the power of 9, 28x to the power of 5, 14x to the power of 3. If we differentiate using the usual algebraic rule, we bring the power down. 11 times 4, 44. The new power is 11 minus 1, we get 10. Same thing here. 9 times 2, 18, x to the power of 8. 5 times 28, 140, x to the power of 4. 3 times 14, 42, x to the power of 2. Now here we are differentiating this function using only the algebraic rule. Now if we use the product rule, exactly the same example. This time this is u, this is v. We find the u prime. The u prime is the derivative of 2x cubed plus 4x to the power of 5, which is 6x squared plus 20x to the power of 4. The v is again x to the power of 6 plus 7, plus the v prime is the derivative of v, so it's 6x to the power of 5, and the u is this 2x cubed plus 4x to the power of 5. And then if you expand everything, 6x to the power of 2 times x to the power of 6, you get 6x to the power of 8. 6x to the power of 2 times 7, 42x to the power of 2. 20x to the power of 4 times x to the power of 6, 20x to the power of 10. 20x to the power of 4 times 7, 140x to the power of 4. 6x to the power of 5 times 2x to the power of 3, we get 12x to the power of 8. 6x to the power of 5 times 4x to the power of 5, we get 24x to the power of 10. And for the simplest form, for the highest power, x to the power of 10, we get 20 plus 24, which is 44. And for x to the power of 8, 6 plus 12 is 18, x to the power of 8. And for x to the power of 4, we have only 140. For the x to the power of 2, we have 42. And as you can see, the result is exactly the same as using the basic rule in differentiation, or we can use the product rule. Now, in case you are wondering, then why bother using the product rule? Because obviously here it looks more complicated than using the usual rule. Well, that's because sometimes we cannot expand things. There's nothing we can do other than to use the product rules. For example, if we have x squared times sine x, x squared times e to the power of 3x, x squared times ln x squared times inverse tangent x, there's nothing else we can do other than to use the product rule. Now the quotient rule in the MF19, we have almost exactly the same as the product rule, but we have a minus and all divided by v squared. So if we have u over v, the y prime is u prime v minus v prime u all over v squared. So it's minus instead of plus, and we divide by v squared. So for example, we have 3x to the power of 6 plus 4x to the power of 5 all over x squared. Of course, we can split the fraction 3x to the power of 6 divided by x to the power of 2, 4x to the power of 5 divided by x to the power of 2, which is 3x to the power of 4 plus 2x to the power of 3. And if we differentiate using the basic rule, we get 12x to the power of 3 plus 6x squared. Now using the quotient rule, almost exactly the same example. The u is the numerator, the v is the denominator. The y prime is u prime. The derivative of 3x to the power of 6 plus 4x to the power of 5 is 18x to the power of 5 plus 20x to the power of 4 times v, which is the x squared, minus v prime. The derivative of x squared is 2x times u. which is the numerator 3x to the power of 6 plus 4x to the power of 5, all divided by the v squared is x squared squared. And now if we simplify 18x to the power of 5 times x to the power of 2, we get 18x to the power of 7. 20x to the power of 4 times x to the power of 2, we get 20x to the power of 6, minus 2x times 3x to the power of 6, minus 6x to the power of 7, minus 2x times 4x to the power of 5, minus 8. Actually, this is 8 minus 8 x to the power of 6. I mean, this is 8. And so if we simplify everything, here we have 18x to the power of 7 minus 6x to the power of 7, that is 12x to the power of 7. 12x to the power of 7 divided by x to the power of 4, we get 12x to the power of 3. 20x to the power of 6 minus 8x to the power of 6, we get 12x to the power of 6. And 12 minus 8 is 12. I mean 12x to the power of 2, which is different than this. It's supposed to be 6x squared if we use this usual method. Oh, wait a minute. I mean, this is 4. And therefore, this is 12. I mean, whoops. So, yeah, we get the same result. That's it. I'll see you again next time.